Well, it's a very great pleasure to be here. I first came to Cambridge almost 40 years ago. I was a research fellow at Jesus, and one of the best things that happened to me in my time there was to meet Partha. He wasn't at the university at the time. He was teaching at the LSE, but he was living in Cambridge. And we happened to meet over at Sidgwick site in the tea room one afternoon and realized that how much we had in common and have been collaborating as friends. It's very much a cooperative enterprise, not a non-cooperative enterprise, ever since. And my coming back here this spring is an attempt, perhaps, to recapture those days of youth many years ago with Partha. We thought it would be fun to do something like these lectures. It's very nice that you came to them too, but I think we would have enjoyed doing them even if you weren't here. But thank you for coming. So I'm going to talk a bit about money. As Partha said, some of what economists do consists of creating parables. Their models are sometimes parables, which mean that they are utterly unrealistic, but nevertheless capture something that is real. Now, of course, all models, not just parables, are simplifications of reality, but many models are used as a basis for predicting reality, understanding reality, and as a basis for the empirical work needed to make those predictions and explanations. In the case of a parable, the models are so oversimplified, and I'll be showing you some oversimplified models in a little while. They're so oversimplified that they couldn't possibly themselves be used for empirical work. Nevertheless, they point to something that we want to understand, and later amplifications of those models can then be used for the empirical follow-up. So I think physicists sometimes talk about toy models. What I'm talking about today will be about toy models. And I want to use the example of money as my illustration. So why money? Well, for non-economists, this may seem odd, but turns out that in most economic models, in standard economic models, there's actually no role for money. Outsiders sometimes think of economists as people who are very interested in money, but in fact, I would say the majority of economists don't have anything to do with money at all. And I'll show you why money plays no role in the standard economic model in a few minutes. Now, in this standard model, we can put money in artificially, and that's sometimes done, but it turns out that this really is artificial, and when we put money in, in this rather contrived way, it's not really serving an essential function. So what I'd like to do today, after showing you why the standard model does not accommodate money, is to propose a couple of very simple models where money is in some sense essential. So here's a simplified version of the economist's standard model, a toy version, if you like, and it'll be a world where there are two goods that people exchange, apples and bananas, and there will be two groups of consumers. There will be the apple growers. Each apple grower is capable of producing 1 bushel of apples. And there will be the banana growers. Each banana grower can grow a bushel of bananas. And both these groups want to consume both apples and bananas, and so there will be a motive for them to trade with one another. I'll suppose, to try to accommodate money, that each consumer also has some money. Let's say each consumer has 10 pounds. Well, in the standard economic model, what consumers do is to try to maximize their preferences or maximize their utility. That, in this case, that a consumer would try to get the best combination of apples and bananas that he or she could, given the constraints that their income or wealth impose. So it's a constrained maximization problem. So in the apple-banana model, preferences are over different bundles of apples and bananas. We can talk, I want to make sure that I push the right button to get the laser pointer. Is there a laser pointer here? Yeah. We can talk about one bundle of apples and bananas. XA is the quantity of apples, XB is the quantity of bananas, and we'll say that this bundle is preferred to this bundle by invoking the preferred to sign. But another way of representing this relationship, the idea that this bundle is preferred to this bundle, is by saying that there is a utility function corresponding to those preferences, wherein the utility that a consumer gets from this bundle is bigger than the utility that the consumer gets from that bundle. And usually, for convenience, economists work with utility functions rather than with preferences directly. It's just technically easier to do so. So let's make even stronger assumptions that everybody has the same preferences, has the same utility function. So, and that utility function takes a particular form. It's the utility you get out of apples plus the utility you get out of bananas. if we assume that apples and bananas are traded, there will be prices for apples and bananas. So let PA be the apple price and let PB be the banana price. Then we can represent an apple grower's maximization problem as a constrained optimization. The apple grower will try to maximize his or her utility, which is this expression here, subject to this inequality here. Now, what is this? What does this inequality mean? Well, on the right-hand side is the consumer, is the apple grower's income. Income is derived from selling your bushel of apples. You can sell the bushel of apples at price PA. So this is your income from selling apples. And then we're also assuming that the consumer has 10 pounds in addition. So the right-hand side is total income from sales and from previous income. The left-hand side is the cost of buying a particular bundle XA, XB. This is the cost of buying the apples. This is the cost of buying the bananas. So the consumer will maximize, the apple grower will maximize utility subject to this constraint. And there'll be some solution to that. And the banana grower will do the same thing, except that now the only difference between the apple grower and the banana grower is that the banana grower is getting income out of selling bananas. So that's this expression here. And there'll be some solution to that optimization as well. And I'm using superscripts here to correspond to the person doing the optimization. So this is the apple grower's optimum, and this is the banana grower's optimum. Economists are interested in predicting what is going to happen in a setting like this, in a apple banana economy like this, and we make those predictions on the basis of equilibrium. What is going to emerge when prices have adjusted to equate supply and demand? So what is an equilibrium in the apple-banana world? Well, the prices and the quantities have to be such that the demand per capita of apples sums to 1. This is the demand for apples by a typical apple grower. This is the demand for apples by a typical banana grower. The sum of those demands has to be 1 because there is 1 bushel of apples per capita, per person. And similarly for bananas. But here's where we run into trouble with money, because each consumer starts with 10 pounds and gets additional income from selling apples or bananas. That consumer will want to spend all of this money on apples and bananas. Those, by assumption, are the only goods around. So all of the money will be spent on the apples and bananas, but that means that nobody wants to hold the money after the trading is done. It's not good for anything. All of the apples and bananas have already been traded. No one wants to be stuck holding money which is no longer useful for anything. So there is no room in this model for for money itself. Now that can be addressed in somewhat artificial ways. One very common way of handling this problem is to suppose that people might want money for its own sake, or if not for its own sake, in order to be able to buy goods which are not actually in the model, which are left unmodeled. If we actually put money into the utility function, then people will want to hold at least some money at the end, and so we have the possibility of an equilibrium in which money is used. But of course, that's at the cost of leaving some part of the economy unmodeled. There are these goods which we're not able to actually stick into the model itself. Another even more artificial way of trying to introduce money is to require that at the end of the trading regime, each consumer has to return a certain amount of money to the bank or to whoever is issuing the money. That, of course, is not the way the world works in reality, and again, it's a rather artificial reason for accommodating money. Basically, in the model I've shown you, there's no need for money at all. We could just have consumers trade bananas for apples directly. For each apple that I buy, I would have to give up PA over PB number of bananas. So barter will suffice. But of course, we observe that in the actual world, money is very important. We don't typically see barter, at least in advanced economies. And the question is why not? So what I'd like to do is to show you two toy models which begin to address the missing element in the standard model. So what's missing from the standard model? Well, one thing that's missing in this completely static, timeless model that I showed you is the idea that money can be a store of value. It's a way that consumers can, in effect, transfer wealth from the present to the future. And in fact, there are settings where without money, such transfers would not be possible. And I'd like to show you a famous toy model due to Samuelson. This is Samuelson's 1958 consumption loan model. I'll show you a somewhat simplified version, which crystallizes this idea that money can be a store of value. By the way, before I get into the Samuelson model, let me just go back to the standard model for a minute and make sure that everyone is with me as far as the moral of that story, which was that we couldn't really have money in that model. Does anyone not follow the logic there? Please do speak up, because this is a talk where everything is building on what's come before, so if you miss one step, the subsequent development won't make much sense. Okay, so let me tell you about the Samuelson model. Very simple model. now we introduce time. In fact, time goes on indefinitely, but each consumer does not go on indefinitely. Each consumer lives for 2 periods. She's young in the first period and productive in the first period. She produces apples. And she's old in the second period, not productive anymore, but she still wants to be able to consume. This is going to be a very simple model. Well, it's simple in many ways, but a particularly important simplification is that there's now just one good. In the previous model, there were 2 goods, apples and bananas. Now there's just apples, but the complication or the twist is that now apples are dated. There are apples in period 1, apples in period 2, and so on. So actually, although they're just apples, there are many goods depending on the period. And an important feature of this model is that apples themselves survive for just 1 period. So they're grown, they're consumed, and they're gone. If there are any leftover apples, they're gone by the next period. Another important feature of this model is that there are overlapping generations. Now, a generation is a group of consumers who all live at the same time. They're young in period T, and they're old in period T plus 1. But at the same time, the generation T consumers are alive. They coincide for 1 period with the T minus 1 generation. Those people are old, while the generation T people are young, and generation T also overlaps with the generation T plus 1. The young people of generation T plus 1 are there when the generation T people are old. And the fact that there are old and young people at the same time will be very important for what follows. Once again, I'm going to look at extremely simple preferences, utility functions. My utility for a bundle of apples xt plus 1. Xt are the apples that I consume in period T. Xt plus 1 are the apples that I consume in period T plus 1 is just the sum of the utilities for each of those consumptions. And I want to go through this, what happens in this model twice. First, when there's no money, and then I'll go through the analysis again when we introduce money. So suppose there's no money. Well, if I'm an old consumer, I'm out of luck, because I would like to be able to consume apples, but I don't have anything to offer. I can't produce any apples. We assume that the old are unproductive, and I can't even save apples from the previous period because apples decay and they're gone by the time that I'm old. So there's nothing I can do to acquire apples, and that is going to limit my utility. The only utility I can get is from consuming apples when I'm young. So I will produce a bushel of apples. I'll consume all of those apples in period T. And then in period T plus 1, my consumption will be 0. And so if this utility function v that I am supposing happened to take the square root form, there's no reason why it has to take this form, but to do an explicit calculation, let's assume that it's the square root, then my total utility would be 1. I would get the square root of 1, which is 1 in the first period, and I would get the square root of 0, which is 0 in the second period, and that would add up to 1. Now let's go through the exercise again when there is money. So let's suppose let's suppose that time starts in period 1. In this model, it's actually not necessary that there be a particular starting date, but let's suppose that there is a starting date, period 1, and that old consumers in this starting date happen to have 10 pounds. Well, now they can get some apples in their old age because they have money. Let's suppose that PT is the price of apples in period T. They can get 10 pounds over PT in apples. That each of them can get 10 pounds over PT. More generally, let's suppose that an old consumer in period T has money holdings MT. Then she can buy MT over PT bushels. And in the next period, the old consumer can buy MT plus 1 over PT plus 1 bushels, and so on. What I'd like to do is to look for an equilibrium of this model with money. Notice that in the equilibrium without money that I first showed you, there wasn't actually any trading because young consumers would simply consume all the apples that they grew. There was nothing to trade them for because there were only apples, and the old consumers couldn't buy any of them anyway. So there was no trade in the model without money, but there will be trade in this model where money is introduced.
Could I just ask
Please.
one point? So if she buys MT over PT apples, she no longer has MT money in the next period. So your formula MT plus 1 equals MT confuses me.
That money goes to the next.
That goes to the it's not to the same consumer. It goes to someone who is an old consumer in the next period.
Goes to the person.
That's right. That's the critical thing. So in the standard model, we ask the question: why would anyone ever accept money, given that there's nothing that they can use it for? But if I'm a young consumer, and you're an old consumer, I'm going to be willing to take your money and give you some apples, because next period I will be old and I want to use that money to buy apples then. That's the only way I can buy apples, by having something to offer.
It's clear, yeah.
Okay.
I didn't know that they were two different.
They're two different consumers, yeah. Any other questions about this slide? So what will an equilibrium look like, given that old consumers in period 1 start out with 10 pounds each? Well, it must be the case that unless we created more money along the way, that in each period the money holdings of the people who are old in that period equal 10 pounds per person. And it must be the case that the price of apples in that period is exactly double, because half of one, let's look at this from a young person's point of view. I grow a bushel of apples. Half that bushel I'm going to consume now, and the other half I'm going to sell to old consumers. That means that in order for me to end up with 10 pounds in my old age, 1/2 times the price of apples must equal 10. I have 10 pounds in my old age. I'm selling half a bushel, so that tells us that the price of apples has to be 20 pounds. And I've shown you an equilibrium of this model, but it's not hard to show that this is the only possible equilibrium. Now, what about utility? Well, now a consumer will consume half a bushel when young, half a bushel when old. If we use this square root utility, that means square root of a half when young, square root of a half when old. That adds up to this expression here, which is bigger than 1. So every consumer is strictly better off than in the model without money. Economists call this a Pareto improvement, when you make everybody better off. And it was made possible because although no physical good survives from one period to the next, apples decay, money itself does survive. So, the reason why it can survive is you don't actually even need a physical object for money. As long as you have some way of keeping track of the money that can be ascribed to one person or another, as long as you have accounting, you have infinite lived money. You don't need anything physical for that. Yes?
Just interject, since this is a session, but this is very interesting. But notice in this model, there was no norm.
Right.
And what I'd like to do is just point out that suppose you embed that model without money, and exactly as it is, as the model was specified, without any money, and they're stuck. On the other hand, suppose you have a norm which says that when you're young, you have to give half of your apples to those who are old. Okay? You only live for 2 periods, unlike the model I've shown, but you can see the model I gave you could be easily extended to cover this. So the norm is hand over half when you're young. Then the question is, how do you get punished if you misbehave? That when you're old, the next periods young won't give you. So the Grimm strategy would be, the reduced form of it would be that. So the reason I wanted to mention is, as you can see now, society can go in 2 different ways: work without recourse to money, but with norms, and get there 2 times square root of half. Or it can go to the money way, no social norm, but they have to trust that the value of money will.
That's right. So that raises. I'm glad you said that, because that raises an important distinction between the kind of model I was talking about and the kind of model that Partha was talking about, well, Partha's already pointed to that distinction. For the kind of social norm in the commons model to work, it's important that we be able to identify people by name. If you do something wrong, and I'm supposed to punish you, I have to know that it's you who is to be punished. That distinguishes a model like that from this kind of, this is what's sometimes called an anonymous markets model, in which none of us have to know who any of the other people are in order for this model to function. All I have to know in order to be able to operate is what the prices are and what I'm going to be able to produce. And my optimal behavior is completely independent of other people's actions, except for the fact that I have to believe that the money that I'm accepting now is going to continue to have value next period. So it's only through money. It's only through money that we are connected together, because it's only through the fact that I'm trusting that money will have value that I have to count on other people behaving themselves. Sorry?
Just wonder to what extent we worry about that, just imposing that trust that these young people in period one just accept these bits of paper as magic beans and immediately, as soon as they're produced, understand that they will be accepted when they're old by the next period young. What pins down that trust in money? Is it innate? Is it a benevolent dictator, which I guess could also solve part of this problem of social norm if we gave that benevolent dictator?
Well, historically, it came from money that served a dual function. Before we had bits of paper, which is essentially valueless inherently, serving as money, we had goods themselves serving as money. So even if I am not able to buy very much with the gold that I accept from you today, I still have a use for gold. Gold it has some inherent value as well. And so historically, the way that money evolved was to first have money which had a dual function. It had a store of value function, but it also was a commodity itself, so people were willing to accept it at least for that purpose. And then eventually we got to the point where people were so used to taking money that the money itself no longer had to have inherent value. And that's the way things are today. There was a point, even in the 20th century, when it was still possible to exchange. You had a promise from the government that you could exchange your dollar for an equivalent amount of gold. You can't do that anymore. You're willing. You're able to exchange your dollar or your pound for goods that people are willing to exchange for that banknote. The government is no longer promising to give you gold.
It took civilization a long time to solve that particular.
Civilization. So the way that we got to worthless banknotes was there was an interim period where governments did promise to give you something valuable in exchange for your paper. So you always had a backup.
Is there any discussion within this model of why these guys accept these bits of paper, or is it just a forced? Is it just a statement that this money is acceptable in the model?
The model is not explaining where the trust comes from. That's where history comes in, or a richer model, which looks at the evolution of trust. This is a snapshot of history where the money is already there. Once it's there, we see that people are going to be better off than they would have been had there been no money.
Eric, just putting up the practice point, this is a model with a unique equilibrium, but you could also quite easily have a more elaborate model with multiple equilibria.
Yes.
And one of them is the one in which money works, and the
one
other is
where it doesn't work. Yes.
And we do actually see societies in which money stops working, and they,
Right.
people will stop using the Zimbabwe currency and they start using the dollar and so on. So the multiplicity continues to be an issue.
Exactly. Now, the reason why money has value in this model is because it's the only way to transfer wealth from one period to the other. By assumption, apples don't survive. In reality, of course, there are goods that do survive for long stretches of time besides money. In many societies, for example, land is used as a store of value. And one question that the model I showed you does not answer, but the model to come attempts to answer, is why, if we have long-lived assets like lands, do we need a contrivance, a social contrivance like money? Won't land do perfectly well? And in fact, if we took the model I showed you and instead of talking about money, we stuck in land in its place, land would serve just as well. So the Samuelson model, as it stands, does not help us understand. It helps us understand why we need a store of value and how that enhances everybody's welfare, but it doesn't explain why money has to take the role of the store of value. Something else could. So that leads me to the second model, in which money, instead of being a store of value, is what we call a medium of exchange. So first, let's go back to the apples and banana world. Suppose that I grow apples, but in addition to apples, I want to consume some bananas. In a world where there's no money, you can argue that I'm at a disadvantage because I have to wait until I find someone who has bananas and wants apples in order for me to trade my apples for those bananas. And that could take time. It may take, there might be quite a delay before I can find such a person. This is why the 19th century economist Jevons said that the disadvantage of a barter economy is that it requires a double coincidence of wants. The people who have apples and want bananas have to somehow find and match up with the people who have bananas and want apples. The problem is that this argument against barter is not entirely convincing, or at least it's an incomplete argument. And here's why. If I wanted apples and I had to go out searching for bananas and I didn't know where to turn, sure, that might take time, but in reasonably well-organized economies, I know where to go to buy apples. I go to the apple shop. Or I go to the banana shop if I want bananas. We could even imagine in a super well-organized economy, there might be a spot specifically for exchanging apples and bananas. There's no reason in principle why we couldn't have an apple-banana exchange. So the argument that it takes time to find someone willing to barter with you is weakened by the possibility of making an economy better organized. But there's a deeper reason why the Jevons argument against barter is not sufficient, which is this. If I have apples and I want bananas, I can go to the banana seller and offer apples. Now, the banana seller may not want my apples, it's true, but presumably, even if she doesn't want them, she can accept them and then pass them on to someone else. After all, if I had money, she'd be willing to take my money, so why not my apples? In other words, why can't apples, or for that matter any other good, serve as a medium of exchange? Why do we need some special medium of exchange that we call money? And that's what this second model is going to try to explain. And the idea is just this. If I go to the banana seller and I try to, sorry, I said apple, but I meant banana. If I go to the banana seller and I try to present apples, she might be reluctant to take these apples. Why? Because she doesn't know very much about apples. She can't properly evaluate them. After all, she's a banana seller, not an apple seller. Now, even that might not be a big problem if she had no reason to suspect that I did know about apples, because if we're both equally ignorant about apples, well, the apples might be good, they might be bad, so we agree to exchange at their average value. neither of us knows whether they're good or bad, so we can use apples as a medium of exchange using their average value. But the problem is that, in fact, I might know more about apples than the banana seller does, in which case she might be very suspicious of my apple offer because she knows, since I'm an expert on apples, that I'm likely to try to palm off pretty bad apples, and which she will then be stuck with. So that suggests that money can be a solution to this problem of one person knowing more about a good than the other. Well, as consumers and producers, in a world where there are just apples and bananas, perhaps it doesn't make much sense to suppose that banana sellers don't know anything about apples. But in actual economies, there are lots and lots of goods being traded. Any single consumer is going to know or is going to be an expert on only a small fraction of them. So we can evaluate the goods that we buy and sell on a regular basis, but most goods we don't know how to evaluate because we don't really care about them. And if someone tries to pay us with a good that we're not familiar with, we will rightly be suspicious. We'll be afraid, and justly so, that we're going to be stuck with the bad apples. This is what economists call an adverse selection problem, and I would like to suggest that an important reason for having money is to solve this adverse selection problem. So roughly speaking, money is a good that can be evaluated by all traders. Before we were talking about the historical antecedents to banknotes. So for many centuries, gold was used as a very important form of money. Why gold? Well, first, it had some inherent value. It could actually be used for jewelry and for other purposes, but also it could be evaluated in a fairly straightforward way. In fact, Archimedes discovered the way for evaluating gold. You can perform a specific gravity test, and you don't have to know very much to be able to do that test. So money is a good that can be evaluated by all traders, and therefore it's a device for overcoming adverse selection. I'd like to develop that idea by using a model that Abhijit Banerjee, who's an economist at MIT, and I developed some time ago. What this model is going to assume is that in the first instance there is no money. There's no government there to issue banknotes or to mint gold coins. Nevertheless, we'll see that there will be a natural way in which money arises endogenously. Now, this money will not be paper money; it'll be commodity money. But you'll see that it emerges out of the equilibrium analysis. So let me show you let me show you how that goes. So this is going to be a model in which there are lots and lots of goods, apples, bananas, and so forth. And each consumer is a specialist in producing one particular good, good I. And when producing this good, the consumer can either produce a high-quality item or a low-quality item. It costs more to produce a high-quality item, but we'll also assume that high-quality goods give higher satisfaction. So if delta C is the additional cost you have to pay to produce a high-quality good over a low-quality good, and delta B is the additional satisfaction that a high-quality good gives in utility over a low-quality good, the assumption I want to make is that delta B is bigger than delta C. In other words, if the economy worked well, everybody would be producing just high-quality goods because the benefit outweighs the cost. I want to simplify matters and suppose that just as each person produces just one good, she also just consumes one good, a different good, good J. And so each person can be identified with the pair of goods, I and J, that she produces and consumes. And I want to assume that any IJ combination is equally likely. You'll see where I use that assumption later on. Now here is the critical assumption about information. We'll suppose that a consumer can tell the difference between high quality and low quality goods if she's producing them, and also if that's the good she consumes, but not for any other good. So basically, each consumer is an expert only about two goods. I also want to assume that all trade is bilateral. That is, it just involves two parties, the person buying, person selling. If there were three or more people involved in any transaction, some of what I said would have to be modified. And if I remember, I will explain why the bilateral assumption is important. I'll suppose that not all of the buying and selling has to be done at once. There are a certain number of periods, capital T periods, in which exchange can occur. So people have time to acquire the goods they want and unload the goods that they don't want. Now here, this is going to be a critical part of the logic. Suppose that I'm an uninformed consumer. That means that I don't know high-quality apples from low-quality apples. And suppose that there's been a sequence of trades under which I managed to acquire high-quality apples. Well, I'm going to show that that such a sequence cannot actually occur, because if there were such a sequence, at some point I must be, or actually it doesn't have to be me, some uninformed buyer must be acquiring high-quality apples from an informed seller. Remember, the only people who produce high-quality apples, the only people who produce apples at all, are people who are informed about apples. So if I'm an uninformed consumer who has acquired some high-quality apples, at some point in the sequence of trades starting from the informed seller who produced those apples, leading up to me, these high-quality apples must have passed from someone who is informed to someone who is uninformed. But that can't be, because if I'm a informed seller and you're an uninformed buyer, I would be foolish to ever sell you anything but low-quality apples. You can't tell the difference, so I'm going to give you the low-quality stuff that costs me less. So there's no way that an uninformed consumer can ever get hold of high-quality apples in an economy like this. And that means that in every transaction, in every bilateral trade, at least one of the goods has to be low quality. So even though I made sufficient assumptions about this economy to guarantee that only high-quality production was efficient, the benefits outweighed the costs of producing high-quality goods. Nevertheless, we need low-quality goods, at least some low-quality goods around, simply for the purpose of exchange. Except, well, there's one exception to that argument, which is that if an IJ trader happened to meet up with a JI trader, and they were both expert about both goods they were trading, then they could exchange high-quality goods with one another. But remember, I assumed that there are many IJ pairs, and so the probability that we got just the right combination of buyer meeting seller was very low. This is related to what Jevons was saying about the double coincidence of wants, but it's for a somewhat different. The logic behind it is somewhat different, because this argument relies critically on information, the ability to distinguish between high quality and low quality. So let me just pause for a moment and make sure everyone is with me up to this point. Yes.
You assume that anyone who buys and sells apples is an expert in apples.
Anyone who produces apples and anyone who consumes apples is an expert.
So if this person who was given a low quality apple were to sell it to somebody who consumes it, they would find out that it was a low quality apple by the fact that this new person has more information, if that makes sense. So they would then know that the person they bought it from was giving them misinformation and giving them a bad price. So would they surely not punish them by not doing trades for them in the future? Would that not even itself out?
Okay, so this gets back to social norms again. If we lived in a world which was small enough so that all the traders knew one another, and even though I was not an expert on apples, and you are an expert on apples, I could still get, in that case, I might be able to get high quality apples from you, because if you tried to rip me off and give me the low quality apples, you would be punished by people not coming to your shop anymore. Yes, that's a possibility in a world which is small enough so that people know who one another is. The model that I'm showing you now is more akin to the Samuelson model. That is, you should think of it as a model where there are not only lots of goods, but lots of anonymous people, so that I really don't know who it is I'm trading with. And if you take advantage of me in our trade, there is no mechanism in place for retribution. In fact, in this model, we don't even really need a government there even to enforce contracts, because all transactions are what economists call spot transactions. I'm giving you something now, you're giving me something now, we just swap. We don't need anyone to enforce our exchange, because it's happening, everything is, the exchange is happening at the same time. It's not as though you're giving me something today and I'm giving you something tomorrow. So it's a large, anonymous, and basically enforcement-free sort of economy. Does this fit every circumstance? Absolutely not, but it probably does fit a lot of European economies in medieval times. They were large and reasonably anonymous.
To come back to your thing, it's a very good question. The way it really fits into what we were discussing before coffee break is that instead of interpreting it the way I had done in the repeat game, imagine that the discount rate R that I was using is interpreted as the probability rate of not meeting the following year. People don't live forever, or it's a mobile society. So I may run into you next year, but I don't know for sure. Then the lower the chance of meeting, the higher is the R. And therefore the less the possibility of cooperation, which was the theorem that I proved. In the limit, R is very, very large, and you are going to be in the bad equilibrium. Inevitably, there's no way of rescuing.
Your question is also related to something I was saying before, and now is the opportunity to explain why I said that all trade had to be bilateral. which means in particular you can't have a third person there. If you did have a third person there, that third person might be an expert. And so even though I can't tell low quality from high quality apples, that person could, just like a judge might be able to, and that would get around the problem too. Well, I'm running out of time, so let me get to the punchline of this model, which is that if there are sufficiently many periods that people have to trade, then just as the Samuelson model had a unique equilibrium, this model has a unique equilibrium, and in that equilibrium there is only one good that is ever produced at the low quality level. And that's the good that will serve as money. Now you might say, well, can we make a prediction about what that good is? And the answer is yes. It will be the good for which the discrepancy between high quality and low quality, delta B, is smallest, because that's the good for which it makes the least difference that we're producing low quality rather than high quality good. This is a model where, in effect, money arises endogenously. No one has to create it. It's there. It's one of the commodities, and it's the commodity or the good for which the cost of the cost of adverse selection, the asymmetry of information, is smallest. Now, one final point. Suppose that the number of trading periods was not only big but very big. We sent it to infinity. Well, it turns out then that the amount of low quality good that we need in order to make this economy work, where the amount of low quality good that we need in equilibrium, will be very small. It'll actually go to zero. And the reason is that the same bit of low quality good can be reused in many different periods for trade. I know that there are a few economics students in the audience. If you've heard of the quantity theory of money, you may recognize that this idea is related to the velocity of money. The faster money circulates, or the more time money circulates in the economy, the less of it you need to conduct transactions. Now, of course, there's still an inefficiency in this economy. We don't want to have any low-quality good at all, because people are better off with high-quality goods. The fact that we're distorting production for this simply to have a medium of exchange does entail a loss of welfare. In the same way that spending enormous resources looking for gold is a distortion of the economy. It's more efficient to have paper money, but in order to have paper money, you probably have to have an economy like the one that I've shown you first, because so people are used to using something as a medium of exchange. Eventually, you can replace that commodity money by something which really is worthless. And with that observation, let me stop and thank you. There are questions? Yes.
Will your model change if you take into account that some of the trading
is not with goods and services. And if you take into account that not everybody is both a producer and a consumer, you take into account that there are female people in the population who stay home and they don't produce, let's say, something.
Well, services can certainly be accommodated in this model. And even if you don't produce a service that I can use myself, you still might be able to offer it to me because you can write down on a piece of paper, I promise to perform service X for the bearer of this piece of paper. So services in principle can be handled in the same way that ordinary goods can be handled. It's just a little bit more cumbersome because you need these extra pieces of paper.
Then you introduce money.
Well, you introduce something that's related to money, but is direct. Again, it's directly it's directly related to a particular service. So it's not quite money, but it's on the way to money.
The story the anthropologists tell is that money begins as a unit of account, begins as part of credit systems. Socially is operated by a temple, and originally money is sort of written in units of wheat.
Yeah.
And then later they use barley because barley apparently is more uniform in size and weight. So I'm wondering if you
I
have.
think that's consistent with, with this
so I was
story.
going to say, do you see this as consistent? And I wonder if you have any thoughts then why we go from wheat to barley, but then how do we end up with things like gold and silver?
So we want a good which people can evaluate. And can evaluate not only physically, but can evaluate insofar as that good is going to continue to be serving as a medium of exchange tomorrow. That is, if I accept your wheat or your barley today, I want to have some idea of what I can exchange it for tomorrow. Now, one problem with wheat and barley, or any agricultural crop, is that supply tends to fluctuate quite a lot. But if supply fluctuates, then value fluctuates. And so that's an argument against wheat and barley. And it's something which tends to favor gold. Now, the supply of gold does change, but it tends to change rather slowly. There are gold rushes from time to time, but not all that often. And so I can pretty much count, or at least historically, I could count more on stability of value of gold than I could when it came to agricultural crops. So that's one explanation. Probably not. There are probably many others too, but that's the story most consistent with this story. No.
In the introduction to this model, you mentioned delta B and delta C and Xij having equal probability and various mathematical assumptions.
Yes.
And when you presented your results, you basically didn't show us those things again.
Yes.
Perhaps it was hidden in your theorems.
Oh, no, the theorems require those. I didn't restate the assumptions, but this proposition requires all those assumptions because if, for example, some IJs were much more likely than other IJs, that would enable a lot of the people in the economy to be able to exchange high-quality goods for other high-quality goods. this proposition relies on the fact that almost all transactions will have to involve at least one low-quality good.
My question is really this: is it interesting, or have you been able to extend your model more generally? For example, each consumer might actually consume a number of goods
Sure.
and be expert in a number of goods,
Right.
and these probabilities might not be equal, and so on and so forth.
Yes.
One could imagine all kinds of mathematical elaboration.
That's right.
Has that been done, or is it interesting?
It is interesting, and it's still in the process of being done. It's fair to say that this model is still in need of full development, and that was my initial point about models as parables. At the moment, this is still a parable, because we don't have the Samuelson model was originally a parable, but it's now its successor models have now been elaborated to the point. The assumptions have been relaxed to the point where you can do sensible empirical work on that. This model, not so much. I mean, there has been some empirical work done on elaborations of this model, but it's still early days. So the results can be extended theoretically and therefore used for empirical purposes up to a point, but we don't know yet quite where that point is.
Well, I think it's 5:10.
Yeah, I've kept you too late.
John has had to leave.
Yes, right. I knew that he had to
So
leave.
he's asked me to...
Stand here just for a moment.
Yeah.
Oh, sorry, John is here.
Oh.
Sorry, I thought you...
No, I have to get a train, so forgive me. By all means, dally and converse at length, but I just want to remind you that this is the first part of a three-part event, and next week we'll have Eric Mascom on credible threats, and Partha will be speaking about sustainability and the welfare of nations. And I do hope that you'll all come back to the same place, same time, next week for the next all this lecture.